Welcome to Lesson 4.3. As you go through high school, you're going to be introduced to many different forms of equations. In this lesson, we're going to look at some of the more basic ones that you are going to be introduced to in grade 9. So I want you, if you're at home, to get a 20 centimeter piece of paper, and I want you basically to make a ribbon out of it, which is 20 centimeters long. So once you have that piece of ribbon that's 20 centimeters long, the question is, how many ways can it be cut to two pieces? Well, if you think about it, you could cut it at the 1 centimeter mark and have 1 centimeter and 19. You could have 5 centimeters, the first piece 5 centimeters, and the second would be 15 because they do have to add to 20. But what if you cut it at 1.1 centimeters or 0.43 millimeters? So you should be able to see that you can cut this thing in an infinite amount of ways. So I want you to take your piece of paper, and just for ease of doing all the math, I want you to cut on centimeter values, but it's not because you have to, it's because I want to make the math easier, okay? So pause the recording, and I want you to cut your piece of paper. Now looking at your two pieces of paper, what stays the same in this problem? Well, regardless of how you cut the first piece and what you had left over on the second, when you put them together, they will always make 20 centimeters because that's what you started with. So could the two pieces be any length? Any length. Now be careful there. There's some restrictions here. We only have a 20 centimeter piece of paper. So that means that you can't have a piece which is 21 centimeters because our piece of paper isn't long enough. So we have a restriction that's got to be between 0 and 20. Now, could you cut it at 0? The answer to that is no, because if you have a 0 centimeter piece, that's basically nothing. So you'd only have one piece left over, which means you wouldn't have cut it in half or cut it into two pieces. The same rule goes for 20. You can't cut it to 20 because you basically wouldn't have two pieces. So you have to cut the two pieces between the lengths that are between 0 and 20. So what are the two variables in this relationship? Well, we have dependent and independent variables. The independent variable is going to be the length of the first piece. The dependent variable is going to be the length of the second piece. And the length of the first piece, when you select it, will determine the second piece's length. So the second piece is always going to be dependent on the first piece of paper. So if you were in my class right now, what I would have done is I would have gone through and chosen 5 or 6 people and said, okay, what were your lengths? And they would have told me, and I would have put them in the table here. And I would be looking for, okay, if someone said, well, my first piece is 20, then I know, sorry, it's 2, I know that I have to get to 20, so the second one has to be 18. So I would be looking for someone to tell me 2 and 18. Likewise, the next one, 9 and 11, because 9 plus 11 is 20. You could choose any lengths, but what ended up happening is they always have to add to 20. Right. Now, because these are random, I would have chosen them from students in different locations. There's nothing, these won't be in order. Okay. So now what I want to do is let's take and graph this. So remember, length 1 is our independent. Length 2 is our dependent. So I'm going to grab my pen up here. And 2 and 18. So 2 is there, and 18 is there. There's my first piece of my first coordinate pair. Now I have 9 and 11. Well, 9 is halfway between 8 and 10, and go up. 11 is between 10 and 12, so there's my second pair. So that one's done, and that one's done. Now 13 and 7, go over to halfway between there, and go up to 7, which is between 6. There's my next piece. And then 5 and 15, 5 and 15 is right there. And 19 and 1, so 19 and 1. Now these were all randomly chosen. I could have chosen 6 and 14. And you should notice something as I start putting in other pieces that this is forming a straight pathway. So now that I know the data is in place, do you have to join the points on your line? Now to determine this, you have to ask yourself a simple question. Is it possible to have a length which is anything between 0 and 20? Could it be 2.2? Could it be 2.8? Could it be 2.9? All right. If it could be anything in between here, It will be a continuous linear relationship. That means you would have to put a line there. And if I'm good at my plotting, everything should land on my line. But I'm not exactly perfect. So this is what your graph should look like. So, do you have to have points? Yes, you do. Now, if I want to represent this as an equation, I have to select a variable for my two pieces of paper. So what I'm going to do is I'm going to choose the letter A to be the length of the first piece, and I'm going to choose the letter B to be the variable representing the length of the second piece. So if I take A and B and put them together, they've got to equal 20. So there's my equation. And this is the way I can double check things. If A and B don't equal 20, then the coordinate pair won't land on this line. So if you were plotting something and you got a point over here, right, automatically I know that this point is improperly plotted because it should be over where this one is. Everything has to land on this line. So how can I tell that? How can I tell if any of them? Well, I always just check to see if they add to 20. If they do, then I know you've done it correctly. Let's try another one. Two integers have a sum of 5. Now the first thing you should have noticed is, okay, we have integers. Now integers are special numbers. They are whole numbers that are positive and negative. That means they don't have decimals and they don't have fractions in them. So you can't have an integer which is 1.5. You can't have an integer which is negative 2.4. They have to be negative 1, 0, 1, positive 2, positive 3, etc. So I've just chosen some variables here. Sorry, some first integer values of negative 6, negative 4, negative 2, 0, and then 2, 4, and 6. And they have to add up to be 5. So what do I add to negative 6 to get to a 5? Well, from negative 6 to 0 is 6. And from the 0 up to the 5 is another 5. So that means I get 11. Now, that means that well, I guess I can't do that one. So I'll just click this off here. So that's 11. Now to get from negative 4 to 5, I go from negative 4 to 0, which is 4. And then to get from the 0 to the 5, I had another 5, so 4 and 5 is 9. Likewise, I can go through negative 2 and add 7, 0, add 5. At 2 to get to a 5, I only have to add 3. From 4 to get to a 5, I add 1. And of course, once I get past 5, I have to start adding a negative number, so because I have to get to 5. So positive 6 plus negative 1 equals a 5. So now taking a look at the first part, our first independent variable x, says how many values are there? Well, if you look at the question, it doesn't say that there's any restrictions on what these integers can be. They can be anything. So I could have negative 1 billion. I could have positive 1 million. There's an infinite possibilities here. Now, when you do this, be careful because you're going to graph this. So if you start taking values which are really, really big, it's just going to make it much more difficult for you to be accurate. So always choose numbers which are easy to work with. Now, how many values of x? What are the restrictions on the value of x and y? Now, I'm going to include y here too because they're the same thing. X must be able to be combined with a number so that it makes 5. So there are restrictions here for x. It has to be an integer. It cannot be anything else but an integer. And when I take that x value, say of 1, and I want to make it into a 5, that means 1 plus 4 makes 5, so my y value is going to be 4. So what I want to do, what I want you to do is I want you to take all this information here, and I want you to go on to the next page, and I want you to graph it. Right? So pause the recording, and I want you to graph this graph, and then we'll do it together. Okay, so first, x is always on the horizontal axis, horizontal, and y is always vertical, up and down. So my first pair is going to be negative 6 on the x and 11 on the y. So I'm going to go to negative 6 first. There's negative 6. What I think I'm going to do is I'm just going to grab a little thicker line so my dots are bigger. Negative 6 right here, and I have to go up to 11. So negative 6 and 11 is right there. Right? Negative 4 and 9, so there's negative 4, and I have to go up to 9. There we go, right there. And negative 2 and 7, right there. 0 and 5, boom. Positive 2 and 3. 4 and 1, and 6 and -1. Look at the pathway that we formed here. It's a straight line. If you were doing this and you had a point pop up over somewhere on the side, you know you made a mistake. And I'll give you a little bit of help. Every line in grade 9 is going to be linear. We do not do nonlinear values in grade 9. We only do linear ones. So if you ever get a point that's not in the pathway of your data, then you know you've made a mistake. So the question now is, do I add a line? Do I join all these points with a line? Well, if you go back to your original question, we said that these were integers. So that means that my value of x can be a -6, or it can be -5, but it cannot be between these. I cannot have a -5.5, which means there's no way for data to be between these integers. So that means that these are not going to be joined with the line. They are what we call a discrete value. They are linear, but they are not continuous. So do you? No, because there's no possible values of x between the ones given, because they are referred to as integers. Now let's take a look at graphing horizontal and vertical lines. This is kind of weird because you, up until this point, you've always seen values where you had an x value and a y value, and you haven't had an equation which did not have one of them. So let's take a look at the first one here. Suppose you have no x value in your relation. What if the relation was simply y equals 3? Okay. Now that means that no matter what happens, our second integer, our y, it has to be a 3. There's no way around it. It's got to be a 3. It can't change, right? There's no way you can put an x in this equation to change the y into something else. It sticks as 3. Now, because there's no x in here, that means there's absolutely no restrictions on x at all. Regardless of what we're doing here, we end up having to have x values which are anything. Now I chose values which will make graphing really easy, from -6 to +6. But the secondary integer, my dependent variable, has to be a 3, right? That's why this is what we call graphing of vertical and horizontal lines. There's no slant here. So can the values of x be any number? Well, if y only can be a 3, x can be anything. There's no restrictions on it. Now, one thing you might want to always check is there a restriction in terms of what kind of numbers they have? And if you look back up here, you'll see very quickly, x has to be an integer. So x doesn't appear in the equation y equals 3, so there's no restrictions in terms of the number you can choose. However, you have to be careful because your x values must be integers also. So I can't have a -6.5. Now, is the y-axis horizontal or vertical? No, I'm talking about the actual axis itself. So here's my one axis, here's the other one. Which of these two is the one which is it's vertical? Well, remember horizon, there's your sun and the line's coming up and it's beautiful, and there's a river coming down and some mountains or whatever. But everything going this way that matches the horizon, that's horizontal. Now, if you can keep that in mind, that means that if it's asked if it's vertical, you're asking the question simply up and down. Vertical is up and down, and horizontal is left and right. So I'm taking a look here. It says, is the y-axis horizontal or vertical? Well, the y-axis is this one, and it is up and down, so it is vertical. Now, on the graph, let's take a look at graphing this thing. Now, I've done this one for you because it's relatively easy. If everything has to be an integer, that means we have to be on what we call the minor lines, and these are the major lines. The minor lines are these ones right here where all of the dots are located, but they have to land on an intersection of two integers. So 1 has to be a 3. 2 on the x has to give a y value of 3. 3 has to give a y value of 3. 4 has to give a y value of 3. 5 has to give you a y value of 3. Now, why does it have to be y value of 3? Because right here it says y has to be 3. Now, why do they use dots? Well, they use dots because this is discrete data. It's an integer, which means there can't be a line. There's no integer between 0 and 1. It's either a 0 or a 1. You can't have a 0.5. So these ones are linear. They go on a straight pathway. They are discrete, which means they are not joined with a line. Okay, let's go to the next. Now, if the y-axis is vertical, why is the line horizontal? Now, this is one of the questions that's the hardest things to kind of visualize. The y value is going to stay the same. The horizontal values can go any way you want. Now, if you look back here, this is what I meant by that. The y values have to be 3. There's no way around it. It has to stay 3. But if it's going up and down to the 3, what remains here is a horizontal pathway. So even though it says y equals 3, it's just telling you that the y has to remain 3. And that means this is going to be a horizontal graph when you have a relationship between y and a single number. Let's take a look at one where we have just x. Now, what if there's no x? What if there's no y in relation and it was simply x equals 3? Well, x has to be 3. There's no way around it. What could y be? Well, y can be anything. I chose -6. X has to be 3. Y can be anything. X has to be 3. Y can be anything, and so on and so on. All right? X has to be 3. That's what this says here. X is 3. Doesn't matter what y is. X has to be 3. When I'm graphing this, since x has to be 3, I can go up and down on the y-axis all I want. All right? Now remember, we're working with integers here. So 2 has to be a 3. 3 has to be a 3. 4 has to be a 3. 5 has to be a 3. All the x values are 3. So when you're doing your coordinate pairs of 3, positive 4, you're going to go over to the 3, up to the 4. Over to the 3, up to the 5. Over to the 3, down to the -4. But every x value has to be 3. How can you tell if a line is going to be vertical or horizontal? Now, vertical and horizontal means that if it's going to be horizontal, you can't have a y in the equation. Right? Now, the line is going to be horizontal. Sorry, let's reverse that, okay? You can only have a y in the equation. I can't even read my own notes. If it's going to be horizontal graph, you only have a y in the equation, no x variable. If it's going to be vertical, there will be no x in the equation, and you'll only have the y. So what I'd like you to do in your notes is just quickly write me down 2 equations which would result in a horizontal graph. So just take a second and do that. And while you're at it, why don't you do the vertical one too? All right, so if it's going to be horizontal, that means it has to have a y, only a y. So this could be y is equal to 4. This one could be y is equal to -3. My 2 examples of a vertical relationship can only have x in them. So x can be 4, or x could be -12, or x could be anything. So in order to know if you're correct, for this example here for a horizontal relation, you should have had y is equal to a number. Right? This one over here, you should have x is equal to a number. Now the number you choose depends on whether you need integers or whatever. Okay, let's see what you've done here. For our first equation, we're going to work with y is equal to -2, right? So now I know that no matter what the x value is, y has to be -2. So I'm going to go to the y is equal to 2, -2. So y-axis is right here, -2 is right there. Now, y is equal to -2 is going to be horizontal because the y has to stay on this level. It doesn't matter, what the x is. It's going to go both ways forever. So it can be 2, but that's got to be -2. X can be 4, but y is -2. X can be -3, but y has to be -2. So you could see that we have a line right here which is going through the negative. This is not, there we go. It's going through the -2. So this is your y is equal to -2. Right? Now let's take a look at the next one. I'll change color for that one. All right. Let's go with, I don't even know what color that is. Okay, let's go with y is equal to 3. Now again, y has to be 3. It doesn't matter what x is. So let's go over on the y-axis. Let's find our 3. It's right there. So it doesn't matter what x is, y is 3. If x is 2, y is 3. If x is 4, y is 3. If x is -4, y is 3. So we have a line going through those points on the y is equal to 3. Now let's take a look at x equals 4. And for x equals 4, it says here x is 4, so I'm going to go on my x-axis, and I'm going to find 4. There it is right there. So x is 4. Now it doesn't matter what y is, right? Everything's going to start with a 4, so it's going to be 4, comma 1, 4, comma negative 3, 4, comma negative 5, 4, comma 5, right? But you notice they're all up and down. This one here is what we call a vertical graph. Taking that, it's going to look like that. Oops, maybe not that crooked. There we are. Now, let's take a look at the next one. And for this color, we'll choose, I don't know, we don't have a blue one yet. So this one, x is equal to negative 3. So again, no matter what the y value is, x is going to be negative 3. So it could be negative 3, 2, it could be negative 3, 3, it could be negative 3, 5, it could be negative 3, or negative 3, negative 5. Doesn't matter. X stays at negative 3. So that means we have a line that goes through there. So those are the 4 equations. And let's take a look at the next form. Now we're going to look at what's called the ax plus by equals c format. This is an equation type that we're going to be using. Now sometimes the relation is not given in the form that you're normally used to, where it says y equals something. This is the form you've been using, as we've been going through this. And here's a couple of them right here. You can take a look. It's y is equal to 2x plus 4, or y equals 3, or x equals 7. And now we're going to be taking and changing it to look like this. Now, here's our first example. Graphing the relation 2x plus 3y equals 6 for the values of negative 2, 0, and positive 2. So what I'm asking you to do here is substitute in the values of x and find out by using algebra what the value of y equals. You have to isolate the y. Okay. Remember, this is like hockey. Remember I told you that you're going to substitute in negative 2. He's going to come in for player x. Player x takes off, and negative 2 is going to take his place. So there's our first equation, and there's negative 2 substituting in for the x. Now we have to do some math. Negative 2 times 2 is negative 4. Nothing else changes here. Now to get the y by itself, I have to get rid of the negative 4 first. I have to change it into a 0. So negative 4, if I add a 4 to it, that'll make that 0, but whatever I do on the left side, I have to do on the right also. So this becomes negative 4 plus 4. That will become 0. And of course, 6 plus 4 becomes 10. So now this is a 0, leaving me with 3y is equal to 10. Now to get rid of a variable that's being multiplied, a constant multiplied by the variable, to get rid of the constant, you divide by that constant. So I'm going to take 3y equals 10. I'm going to divide this by 3 and also that by 3. Now, 3 divided by 3 is 1, so I just have y on the left, and then 10 divided by 3, you could leave it as a fraction, but as an improper fraction, but that's pretty easily done as 3 1/3. So there's my value. Y is 3 1/3. Now, when we're doing this, remember, I'm going to be marking you based on formula, substitution, and answer. That's always what it's going to be. Formula, substitution, answer. F, S, A. You'll see me writing that all over the place. I even put it in the question sometimes to help you. Now, let's go to the second value. All right. I now know that I've got to do it for 0. So I'm going to substitute 0 for the x position. So there's my first equation. 2x plus 3 is equal to 6. Take out the x and put in the 0. Now, 2 times 0 is 0. So this leaves me with 0, which goes away, leaving me with 3x is equal to 6. Now, so I said 3y is equal to 6. Now divide both sides by 3. 3 divided by 3 is 1. That leaves you with just y on the left. And 6 divided by 3 is 2. So there is your equation set up for your algebra for the second one. Now remember, formula, substitution, answer. 3 marks. Now, the last piece, if you look up here, it said I wanted you to do it for negative 2, 0, and 2. So on the next page, we're going to work with the value of 2. So here's our formula. 2x plus 3y equals 6. Take out the x, put in the 2. 2 times 2 is 4. Now to get rid of a 4, I've got to put a negative 4 with it because that's our 0 principle. The two numbers to get to 0, you had a positive and negative of the same magnitude. So a negative 4 and a positive 4. So 4 and a negative 4, and remember this is a negative 4, All right, subtracted 4 is the same as a negative 4. If you remember back to before, if I gave you 4 plus negative 4, this was adding the opposite. And we always did this when we were doing integers. So 4 take away 4 is the same as 4 plus negative 4. So 4 take away 4 is 0. And 3y then stays the same. And of course 6 take away 4 is 2. Now divide both sides by 3. 3 divided by 3 is 1. And of course 2/3 remains as 2/3. So we now have our table of values. Now remember, formula, substitution, answer, and if I ask you to make a table of values, you're going to get 3 marks there also. Now we have to graph these. Now we're going to have to do some estimating because 3 1/3 isn't on my graph. I chose whole or integers, so it's not that difficult. So to do my first pair, -2 and 3 1/3, I'm going to go to -2 on the x-axis. Remember, this is always the x-axis and this is always your y-axis. So -2, I'm going to go over there. And now it says to go up to 3 1/3. So there's 1, 2, 3. Now I've got to divide this into 3 parts, right there and right there. Right, so there's 1/3, 2/3, and 3/3. So this is going to be 3 1/3, which means I'm going to be taking and I'll turn this to black and bump it up in size. So my 3 1/3 is going to be right there. 0 and 2, right there. And now 2 2/3 go over to 2. Now we're going to go up 1/3. There's your 2/3 right there. Now if you want to know whether you did it correctly, all right, you can just think of it, what would it look like if I put a line through it? Would it actually line up through all of the points there? All right. And if it goes through the line of all the points, then you know you did it correctly. Now let's go back and say, take a look here. Does it say anything about these numbers being integers? I know it gave us the numbers to use in our graph right here, -2, 0, and 2, but it doesn't say anything about them being integers. Now because of that, that means that we have to join these with a line because we do have values between 0 and 1 which we could have used if we wanted to start working with decimals or fractions. But we don't. We want to keep it easy. That's why we used simple numbers there, -2 and all that stuff. Okay, next question. Here's one that I want you to do now. You've got 2x plus y equals 4, and I want you to take and create a table of values for these values of x, and then I want you to graph it. So I'll pause the recording and do the whole equation. Okay, first things first. I have to get rid, so I have to take the equation. There's my equation. 2x plus y is 4. Take out the x and put in a -2. 2 times -2 is -4. So I have -4 plus y equals 4. Add a 4 to both sides. This will become a 0. So you'll end up with y is equal to 8. Okay? Now, going to the next one. Now I'm going to take and put x equal to 0. So there's my formula. Take out the x, put a 0 in. 2 times 0 is 0. And now I'm left with just y is equal to 4. And +2. There's our equation. Take the x out, put in the +2. 2 times 2 is 4, plus y is equal to 4. So subtract 4 from both sides, and you end up with y is 0, because 4 take away 0 is 0 over here. So when you put all these in the table of values, -2, 8, 0, 4, and +2, 0, this is what your table of values is going to look like. Now, when I'm marking this, be aware, formula, substitution, answer. Formula, substitution, answer. Formula, substitution, answer. Did you put the 3 things in here? So we haven't even gotten to the actual graphing yet, but we're already sitting with 3, 6, 9, 12 marks. All right, let's go to the next one. So if we have to graph an equation, I can't remember if I told you this on the previous one, but remember this. First thing you need to do is you've got to take and write the equation that you're graphing as your title. So I'm going to be using, come down, give me, there it is. Let's go to 14. So this is 2x plus y equals 2x, that's small, doesn't matter. 2x plus y is equal to 4. So there's my graph right there. Now, if you want to put graph of, you can do that, but I have to have a title. Now, I've already told you what the x value and y values are. There's no real word problem here, so this isn't cost versus whatever. So it's just the value x and the value y. Now, -2 and 8. So I'm going to grab my colors here. I'm going to go to blue this time, and maybe a little smaller dot. So -2, 8. So here's -2 all the way up to 8. 0 and 4. So there's 0 all the way up to 4. And 2, 0. So we'll go to 2, and you stay at the y value of 0. Now, do we join it with a line? Go back up here. What's it say? Doesn't say anything about our values being integers, so yes, you're going to need a line. And your line is going to go through all of your points. And hopefully I can make this work quickly and easily. And there you go. So you see it goes through all of my values almost perfectly. Now remember, if you have points which are off your line, there's a mistake here. Right? They should always line up. So this is what we call linear. Right? It is a continuous graph because it goes on. You use all the data between all the places. And now it's time for your assignment. So good luck. If you have trouble, watch the video again. If not, come in and see me. I'll be more than happy to help you. Okay, take care.